So let's continue. Today is Tuesday, May 5th, and we're going to talk about the northern lights and how that helps us understand Earth's magnetic fields. So the northern lights are definitely something I want to see. I haven't seen them personally yet. You have to be pretty far north or in the southern hemisphere, pretty far south, and it has to be under the right circumstances. So deep in the night, you can probably see these beautiful colors and the Inuit Eskimos, they had nice myths about them. So did the Vikings. From outer space, this is from the ISS, the International Space Station. You can see the northern lights, and then you'll see it's part of the atmosphere. And so what's causing this? Well, it's all about Earth's magnetic field. Now, we talked about magnets. The Earth is, in essence, a really big magnet. And the reason why is because the Earth is made out of iron. And this iron then has a north pole and a south pole, right? And so what it does is it creates this huge magnet that stretches around the Earth. It creates these magnetic fields that go around the Earth. And that's what allows us to use a compass even if we're not close to the North Pole. The magnet is so big that the compass is drawn towards it. Now, a nice benefit of it is obviously the northern lights, but even more important is that the magnets help us protect us from the solar wind. And the solar wind are these strong charged particles that the sun shoots out, and the magnetic field caused by our Earth's core allows it to deflect, and that creates these beautiful northern lights and stuff like that. So I'll show you a quick video about the Earth's magnetic field.
NASA's Themis mission has overturned a long-standing belief about the interaction between solar particles and the Earth's magnetic field. The Earth's magnetic field is like a giant bar magnet. This magnet forms a protective field around the Earth, shielding us from the solar wind that is constantly streaming towards Earth. This shield is called the magnetosphere.
The solar wind is primarily composed of protons and electrons, charged particles streaming out from the sun. Some of those particles have very high energies, radiation energies, and they can damage astronauts and spacecraft. We are shielded by our Earth's magnetic field most of the time. However, a small fraction of the solar wind particles get into the Earth's magnetic field, are energized, and become the Earth's radiation belts, which can damage spacecraft and harm astronauts.
So hopefully that video helped explain why the Earth's magnetic field is so useful and how it protects life here on Earth from the dangerous solar particles. I'll finish off with one more video. This is more of a funny one about how magnets and compasses can be used for navigation, but they can also be uncalibrated. So enjoy. I'll see you tomorrow.
I was taking a class called Orienteering. The class taught us how to read maps and use a compass. And one day it was time for our class to go on a scavenger hunt thing. We were given a list of places we had to go to, and we were supposed to use our compass and count our paces to get to each specific location. Then when we got to our destination, there would be a marker somewhere, and we would have to write down what that marker was. There were 10 different markers that we had to find, and the course was supposed to lead us in a circle. The leader who was in charge of our group and the compass was an older scout named Paul. It wasn't the merch guy Paul, but I think it would be funnier if it was. Our group set off to the first location. Having a compass and counting your steps isn't the most accurate way of navigation, but we weren't allowed to use Google Maps, so. When we got to the spot, we had to look around for a little bit to find the marker, but we eventually found it, and then we were off to the second location. This time, the marker was harder to find. The spot we landed on was pretty far from where the marker actually was. At the third location, we couldn't find the marker. But we did see this reflective sign on a tree, and we figured that's what the marker was supposed to be, so we wrote it down. At this point, I decided to grab my own compass and give it a try. My compass pointed in a direction that was a little bit off from Paul's direction. Not by a whole lot, but just enough. But remember, I was the little kid. Nothing I said mattered. Paul said things to me like, "Oh, you don't know how to use a compass. I bet yours is broken. I'm never going to work for you one day." And you know what? I believed him. This guy is 15 years old. Do you know how wise and experienced he is? So we kept going and struggling. We used anything we found as a marker. Some piece of trash, it's a marker. Hey, this tree has an A and an M carved into a heart. Kinda weird that it's at an all-boys camp. Do you think that it's a marker? Eventually, we all had to admit that we were completely lost. The other boys told Paul to hand over his compass, and Paul reached into his pocket, pulled out his compass, and 2 buzz magnets. Buzz magnets are magnets that are shaped like a bullet, and you can throw them up in the air and they make this cool buzzing sound. They sold them at the camp store, so that's why Paul had them. And everyone immediately figured out why we were lost. For those of you who don't know how compasses and magnets work, I don't know either. I think it has something to do with them coming from outer space. A compass is supposed to point to the magnetic North Pole, and a magnet will mess up the direction a compass is supposed to point in. Paul's compass wasn't pointing to his pants the whole time. We would have been suspicious if that had happened. But because his compass was right next to a magnet, it got uncalibrated. And then we all got lost in the woods and died. And that's why I don't have an orienteering merit badge. I was upset because my compass probably wasn't broken, but I didn't stand up for myself. Because I don't do that.